It begins with darkness. Not the darkness of night, nor the shadow cast by worlds, but the darkness that lies between all things. A slow drift carries the gaze beyond the spiraling arms of galaxies, past the scattering of lone stars that cling to the outskirts, and into the deep, airless chasms between them. Here, there are no suns to warm the void, no worlds to anchor the mind. Only distance, vast, immeasurable distance, stretching in every direction. In this gulf, gravity loosens its grip. The nearest star may be millions of light years away. Time itself seems to lose its urgency, slowing into an almost eternal stillness. The silence here is not mere quiet. It is older than the first atoms, older than the galaxies themselves, a silence born in the first fraction of a second after the universe began. And in this silence, light grows tired. Its waves are stretched thin by the expansion of space, pulled into colors no human eye can see, until even the memory of its brightness fades. This is the intergalactic medium, a desert of almost nothing, where each atom may be separated from the next by miles, rarer than the rarest treasures on Earth. Yet it is not empty. In its darkness hide the faintest of whispers, the cold radiation of the Big Bang, ghostly threads of hydrogen bridging the gulfs between galaxy clusters, and traces of something more elusive still, signals that hint at forces moving unseen across this cosmic wilderness. The mystery begins here, in the silence between galaxies, where the universe guards its oldest and deepest secrets. In the early decades of the 20th century, astronomy looked outward with a new sense of scale. Galaxies, once thought to be mere clusters of stars within our own Milky Way, were reimagined as vast, self-contained realms, island universes, adrift in a dark and infinite ocean. The spaces between them were assumed to be perfect vacuums, barren expanses in which no particle, no whisper of matter, could survive. It was Edwin Hubble who first began to redraw this cosmic map. By measuring the faint light from distant galaxies, he uncovered a startling truth. The universe was expanding, every galaxy retreating from every other, carried apart by the stretching fabric of space itself. With this revelation came an even greater appreciation for the separations between galaxies, distances so great that even light could take millions of years to bridge them. For a time, these gulfs were imagined as pure nothingness. But in the mid-century, the first ears of radio astronomy began to listen. They detected faint, diffuse murmurs coming from regions far removed from any galaxy. This was not the silence of a perfect void. In 1964, at Bell Labs, Arno Penzias and Robert Wilson encountered a persistent hiss in their radio antenna, a signal they could not silence. It was the afterglow of the Big Bang, the cosmic microwave background, bathing even the deepest intergalactic darkness in ancient light. The void, it seemed, was not empty but steeped in the memory of creation. In the years that followed, the light from distant quasars, beacons from the early universe, revealed something stranger still. Their spectra carried forests of shadows, the Lyman alpha forest, etched by thin clouds of intergalactic hydrogen lying between the quasars and Earth. By the 1980s, the idea of a featureless void had collapsed. Margaret Geller and others began mapping the large-scale structure of the universe, unveiling the cosmic web, vast filaments of matter threading across unimaginable distances, galaxies strung like dew along strands, separated by immense, yawning voids. The silence between galaxies was no longer pure absence. It was a structure, delicate, ancient, and alive with the faintest traces of the universe's hidden design. They had once called them voids, the dark chasms between galaxies, the unlit spaces where nothing stirred. But as the instruments grew sharper, more patient, and more attuned to the faintest whispers of the cosmos, the emptiness began to speak. It was not silence they found, but a hidden ocean. Filaments of intergalactic gas, thin beyond comprehension, threaded through the darkness, stretching for millions of light years. Plasma, heated to millions of degrees, drifted unseen except in the ghostly glow of X-rays, a glow captured by satellites orbiting far above Earth's haze. The Chandra X-ray Observatory, XMM Newton, and others revealed halos of searing gas surrounding galaxy clusters, reaching deep into the spaces once thought lifeless. These halos were immense, larger than the galaxies they cradled, their boundaries fading into the intergalactic medium like fog into night. The discovery came with a startling calculation. More of the universe's baryonic matter, the ordinary atoms of protons and neutrons, existed outside galaxies than within them. The vast majority of the matter that makes up stars, planets, and life was not locked inside spirals of light, but drifting in the gulf between them. And yet, even this was not the full accounting. Simulations of cosmic structure predicted more matter than telescopes could see. This became the missing baryon problem, the hunt for mass that cosmology demanded but observation could not confirm. It was suspected to be hiding in the warm hot intergalactic medium, a tenuous network of gas at temperatures between 100,000 and 10 million degrees, invisible except in the faintest X-ray and ultraviolet signatures. Then came stranger hints. Sensitive radio surveys began to detect faint, unexplained emissions from deep voids, signals not from stars or galaxies, but from the darkness itself. They were weak, almost drowned in cosmic background noise, yet persistent. Some pointed to synchrotron radiation from electrons spiraling in magnetic fields that stretched across intergalactic distances. Others hinted at processes still poorly understood, perhaps linked to dark matter's elusive nature. The realization was unsettling. Intergalactic space was not a passive backdrop, not an inert stage upon which galaxies acted out their lives. It was a dynamic, active ecosystem, matter flowing along invisible filaments, heated and stirred by cosmic winds, threaded with magnetic fields older than the first stars. It shaped galaxies, fed them, and stripped them bare. The voids were not dead. They were the slow, deep currents of the universe, a hidden engine, working in silence. The cartographers of the cosmos once mapped only islands, galaxies bright against an ocean of darkness. But in time, their instruments grew more sensitive, their ambitions bolder. And when they began to chart not the islands, but the sea itself, a new shape emerged, the cosmic web. With the Sloan Digital Sky Survey, astronomers turned the night sky into a three-dimensional atlas. Millions of galaxies became points in a vast lattice, revealing an architecture on the largest scales ever seen. Long filaments of light stretched across the universe, converging in dense clusters, separated by yawning voids. It was the skeleton of the cosmos, not a random scattering, but an intricate network shaped by gravity and time. Yet even this map showed only the visible. To glimpse the invisible threads binding this structure together, astronomers turned to nature's own lenses. Gravitational lensing, the warping of light by mass, revealed bridges of unseen matter between galaxies. These were the filaments of dark matter, their presence betrayed only by the bending of light from background galaxies, tracing highways of gravity through the void. Within these bridges flowed something stranger still. The Hubble Space Telescope's Cosmic Origins spectrograph detected the spectral fingerprints of the warm hot intergalactic medium, the WIM, gas heated to millions of degrees, so thin it would be vacuumed by terrestrial standards. It filled the spaces between galaxies, faint and ghost-like, scattering the photons of the cosmic microwave background in subtle ways. This was the Sunyaev-Zeldovich effect, ancient light from the Big Bang colliding with high-energy electrons drifting through intergalactic plasma, each collision shifting the light's energy, leaving a fingerprint in the CMB's texture. High-energy messengers from the farthest reaches, gamma-ray bursts and fast radio bursts, became tools to weigh the void. As their light passed through the intergalactic medium, it slowed, bent, and scattered, its signals stretched and dispersed. By studying these distortions, scientists traced the density and composition of the space it had crossed, turning catastrophe into measurement. Then came a deeper revelation. The voids themselves, these immense gulfs between galaxies, appeared to be magnetized. Faint, primordial magnetic fields stretched across millions of light years, perhaps seeded in the earliest moments after the Big Bang, amplified by the slow churn of cosmic evolution. Quasar light, polarized in strange and consistent ways, hinted at a large-scale coherence, a cosmic order whose origin was not yet understood. Slowly, the perspective shifted. Intergalactic space was not an inert stage. It was an active, interconnected network, a web of matter, energy, and magnetism, pulsing with the slow rhythms of the universe's deepest currents. To understand galaxies, one would first have to understand the dark sea in which they drift. The deeper astronomers peered into the silence between galaxies, the stranger it became. What had begun as a search for the missing matter of the universe, the unseen baryons predicted by cosmological models, had, for a time, seemed on the verge of resolution. The warm-hot intergalactic medium, the WIM, accounted for much of it, but not all. Even with the most sensitive instruments, a stubborn fraction remained unaccounted for, hidden somewhere in the deep dark. Then came another puzzle. Spectra from quasar light revealed unexpected chemical fingerprints in the most desolate regions, heavy elements like oxygen, carbon, and iron adrift in intergalactic gas billions of light years from the nearest star. Such elements can only be forged in stellar furnaces, scattered by the death throes of massive suns. Their presence here implied that galaxies, in some distant age, had bled their contents into the void through titanic outflows, galactic winds and quasar jets powerful enough to push matter across millions of light years. The empty darkness was not entirely pristine. It had been touched by ancient violence. Yet in other places, there flowed something even older, cold streams of nearly untouched hydrogen, never condensed into stars, gliding along the filaments of the cosmic web. These invisible rivers fed galaxies for billions of years, fueling their growth and shaping their histories, a hidden circulatory system in the body of the universe. But the map of the cosmic web revealed structures far stranger than these flows. Enormous walls of galaxies, and even greater voids, appeared too large, too organized to have formed within the 13.8 billion year age of the universe, at least under the rules of standard cosmology. The Hercules Corona Borealis Great Wall, stretching over 10 billion light years, seemed almost to mock the limits of gravitational clustering as we understand them. Its scale whispered of processes beyond the current models, patterns in the cosmos that might have roots before the Big Bang's own horizon. In the radio spectrum, faint, diffuse emissions emerged from regions where no obvious astrophysical source could be found. They were neither from known galaxies, nor from recognized background phenomena. Some speculated they might be the fingerprints of exotic physics, decaying dark matter, interactions between cosmic strings, or processes from an earlier phase of the universe. Others urged caution: interference, unknown plasma processes, or simply artifacts of incomplete mapping. Yet the voids kept their own secrets still. Temperature measurements revealed an unsettling irregularity. Some voids appeared warmer than simulations predicted, their photons carrying an energy surplus with no easy explanation. If not a relic of observational error, these variations could be the imprint of something vast, the gentle push of dark energy sculpting the expansion of space most visibly in these great empty realms. Here, in the silence between galaxies, the fabric of reality might be at its most delicate. Every fluctuation in density, every shift in temperature, every unexplained glow could be a message from the deep, a sign that the voids themselves are the most sensitive detectors of new physics in the cosmos. Not the bustling interiors of galaxies, but the cold, slow breath of nothingness, quietly recording the universe's most profound truths. The silence between galaxies is not only a place of absence, it is a theater for the most profound speculations in modern cosmology. Here, Far from the noise of stellar birth and death, scientists see the fingerprints of forces that shaped the universe long before the first galaxies took form. At the foundation of every map of the cosmic web lies an invisible scaffold, dark matter. It is unseen, undetectable by light, yet its gravity dictates the very architecture of the cosmos. Galaxies do not float at random. They gather along vast filamentary highways woven from dark matter's gravity wells. These structures stretch across hundreds of millions of light years, guiding the flow of gas, stars, and entire clusters. Some theorists suggest that subtle motions within the great voids, the way galaxies drift, the way plasma bends, could reveal the mass, the interaction strength, even the particle nature of dark matter itself. If so, the quietest regions of space may yet expose one of physics' most elusive secrets. Within this framework unfolds the restless cycle of baryonic matter, the ordinary atoms that make up stars, planets, and life. Supernova winds and black hole jets tear gas from galaxies, hurling it into the intergalactic medium. Over billions of years, these outflows seed the void with heavy elements, ensuring that even its most desolate stretches carry traces of stellar history. This is baryon cycling, the slow, cosmic exchange between galaxies and the dark ocean around them, enriching the void as surely as rivers carry minerals into the sea. Threaded through this darkness may be something more subtle still, magnetic fields that span millions of light years. Born from tiny fluctuations in the infant universe, amplified by the turbulence of merging clusters, they whisper across the voids at strengths almost too faint to measure. These cosmic magnetic fields could influence how gas flows, how galaxies spin, and how charged particles move across the deep, cold distances. But some signals defy such explanations. From the darkest voids come faint whispers in radio and gamma-ray frequencies, without a clear astrophysical source. In the halls of theoretical physics, such anomalies inspire visions of exotic particles. Axion-like forms that might subtly oscillate into photons, or dark photons that mix faintly with the light we know. If detected and confirmed, they could open an entirely new sector of physics, revealing matter and forces hidden since the dawn of time. Even the vast topography of the universe invites speculation. The large-scale patterns in the cosmic web, alignments stretching across billions of light years, may not be purely random. They could be the lingering imprint of conditions set just after inflation, the rapid expansion that birthed the universe's structure. If so, the shape of the voids could be a fossil record of the first trillionth of a second after the Big Bang. And in the speculative borderlands of science, some imagine the void not as lifeless, but faintly inhabited. Rogue planets, ejected from their home systems, could wander the intergalactic dark, warmed by internal heat or radioactive decay. Primordial black holes, relics of the earliest universe, might drift unseen, carrying with them ancient matter, or even microbial life encased in frozen fragments of rock. Though improbable, such ideas remind us that the void is not a sealed tomb. In this light, the silence between galaxies becomes both graveyard and womb, a place where dead matter drifts in endless night, and where the raw materials of new cosmic cycles slowly gather. It is the great interval between the universe's notes, a pause that is not emptiness, but potential, holding, in its stillness, the possibility of beginnings yet to come. In the coming decades, the silence between galaxies will no longer remain uncharted. Humanity now stands at the threshold of instruments powerful enough to pierce the faintest whispers of the intergalactic dark, to transform absence into revelation. The James Webb Space Telescope, already gazing deeper into time than any instrument before it, has begun to detect the earliest galaxies, their light stretched into deep infrared by billions of years of cosmic expansion. Some of these fragile beacons appear not in isolation, but strung along invisible threads, the ancient filaments of the cosmic web, their existence hinted at in the way starlight clusters across the abyss. By tracing such alignments back toward the dawn, Webb is not merely finding galaxies. It is mapping the hidden roads that led them into being. Soon, New X-ray observatories like Athena will turn their eyes to the warm hot intergalactic medium, the WIM, a vast reservoir of matter heated to millions of degrees. In its faint X-ray glow may lie the final accounting of the universe's missing baryons, the ordinary matter unseen in stars or gas clouds. Each detection will be a pinprick in the dark, revealing where this hidden mass lies, and how it shapes the destiny of galaxies. On the ground, the square-kilometer array will begin to listen for the faintest radio signals. Bridges of emission stretched between galaxies, remnants of ancient collisions, or the slow pull of gravity across millions of light years. Its vast antennas, spread across continents, will gather whispers so faint they vanish into the noise for all but the most sensitive ears. Meanwhile, the next generation of cosmic microwave background experiments, CMB Stage 4, will refine the measurement of the Sunyaev-Zeldovich effect, the subtle scattering of ancient photons by high-energy electrons in the void. By mapping this effect, scientists will see not just where matter is, but how it moves and evolves, tracing the circulation of heat and energy across the web's strands. Even the dark's most violent moments may soon be heard. Future gravitational wave detectors, tuned to new frequencies, may register the ripples of black hole mergers far beyond the boundaries of any galaxy, the cosmic echo of mass colliding in pure emptiness. Such events would confirm that the void is not entirely still, but occasionally shaken by cataclysm. Supporting these observations are the silent, tireless engines of exascale computing. Simulations now recreate the birth and growth of the cosmic web with unprecedented precision, following every strand of matter, every current of plasma, every subtle fluctuation in the pull of gravity and the push of dark energy. With each generation of models, the void becomes less a backdrop and more a living environment, a system of flows, cycles, and feedback loops that knit the universe together. Here, astrophysics merges with plasma physics, cosmology with computational science, forging an interdisciplinary approach to a mystery too vast for any single field to contain. The long-term ambition is nothing less than total cartography, to map every filament, every bridge, every thread, and to understand the great circulations of matter and energy that traverse the intergalactic night. If achieved, the silence between galaxies will never again be seen as emptiness. It will be known as the vastest ecosystem in existence, a slow-moving, invisible ocean whose tides have shaped the universe since its first light, and will continue to do so long after the last stars fade. In the darkness between galaxies, there is no sound. Not the echo of wind through alien mountains, not the hum of a star's fusion heart, only the endless quiet of space stretched beyond comprehension. Yet in that quiet lies a truth more profound than noise could ever reveal. The silence is not absence. It is the universe listening to itself. The vast intergalactic medium, once imagined as a perfect void, is in fact a hidden archive. Here, atoms that formed in the first seconds after the Big Bang still drift, unchanged, their paths tracing the ancient currents of cosmic expansion. Here, faint radiation from the universe's infancy lingers, its wavelengths stretched by the deepening night. Every photon, every particle, is a fragment of memory, a message from a time before stars, before galaxies, before even darkness had fully settled in. This space, so wide that light itself takes millions of years to cross it, is not lifeless. It holds the seeds of future worlds, the remnants of old ones, and the elemental whispers from which both arise. It is the graveyard of suns and the womb of creation, the interval between beginnings and endings. And in that paradox, that what seems dead may be the birthplace of life, lies one of the deepest mysteries of existence. Drifting here, past the last scatterings of starlight, the mind is drawn inward. Mortality feels small against this scale, yet strangely echoed by it. For like the silence between galaxies, the spaces we think of as empty in our own lives are rarely so. They are filled with the unseen, with potential, with history, with the quiet preparation for what comes next. And so the final image remains, a solitary journey through the darkness, no destination in sight. Surrounded by nothing, and yet, embraced by everything.